Right, everyone. Today, no Welsh Day, I've got a science stroke maths activity for you. It's like a numeracy task. Numeracy is when you apply your mathematical skills to a different subject. Okay, in this case, it's going to be science. So it's linking to your measure work we did last week and looking at those scales. Remember last week we looked at those scales, those clock scales. We looked at horizontal scales and vertical scales. So we're looking at those again today. Okay, you need to read those scales to help you solve the mathematical problem. And it's a mathematical problem, a bit like the word problems I've given you in maths today. All right, but it's all to do with weight. I'm going to read the scenario to you first of all. You are to plan a mission to Mars. You'll be given a list of items you will need to take, and you must calculate the total weight of those items. You'll be required to fuel your ship with the correct amount of fuel. In addition, you will need to prove you can read your instruments accurately and decide on the correct course of action as a result of what instruments show. A mission will be described to you and you will need to read the instructions carefully and decide what you would do in this situation. Okay? Good luck with the test. So your first task will be to fuel your craft with the correct amount of fuel. The current level of fuel is shown below, so it's shown here, 5,000, 4,000. In between 5,000 and 4,000 will be 4,500 as a clue for you. You've got to know what every little mark is worth, okay? All right, so it's halfway between 4,500 and 4,000. Your craft requires 6,750 tons of fuel to make the trip to Mars and back. How much more fuel should the ship be fueled with? Remember, if you take too much fuel, your craft will be too heavy to lift off safely and will crash. Show how much you have worked out. Show how you've worked out how much more fuel you will put in your aircraft. I don't mind if you use a calculator, okay? You might use the big numbers here. I don't mind if you put your workings out with a calculator, that's fine. If you can use a grid method, great. So first of all, work out what's in there already, then work out the difference between that and that. And the difference often means take away. So there's two calculations there, all right? Two calculations. First of all, work out what that is, yeah, and then work out what the difference is between that and that, okay? Remember, you can use a calculator if you want to, all right? Next one, it says, being a British mission, we have little money to spend on food. Following much research, it has been discovered that an astronaut can survive on a diet of baked beans alone. Mr. Court can do that. In order to make the trip, you will need to take 375 cans of beans. As part of the test, you're required to weigh a tin of beans and calculate the total weight of 375 cans of beans. So weigh it at home, get your measuring scales out, weigh it. If you haven't got any beans, you can use a tin of soup maybe. I'm sure you've got some tins at home. Write down what the measurement is. Then you need to do work it out. So you've got 375 of those, all right? So 375 lots of those, okay? All right, so think of what sum that would be. Okay, again, you can use your workings out to do it by hand, or you could use a calculator if you wanted to. That's not a problem. Right, so you got to weigh the beans first. So we're using weighing and reading scales again. The next one's the same. So you've got to have a certain amount of water. You need 546 bottles of water. So you get a bottle of water, you need to weigh that again, and then do a similar sort of calculation as the baked beans. Okay? So what's the weight of the total number of bottles? All right? The next one is about, it says mission test. In order to lift off the launch pad, you will need to generate 3,500 tons per metre of thrust. Below is a thrustometer, which shows the thrust level. Read the dial and record what the thrustometer shows thrust levels as. So think about it. Last week we looked at those little marks. So what's each mark worth? So we've got 3,000, could it be 500, 4,000, that'd be whether 3,500, 4,000, can't be that. So what's each little mark worth? And you've got to measure that and write down what the thrust is. How much more thrust do you need to reach liftoff? Show your workings. Remember, it needs that much, 3,500. So how much more do you need? Okay, again, a little sum there for you to do. To escape Earth's gravity, you need to reach a speed of 810 miles per hour. Below is your speedometer. Okay, read the current speed from the speedometer and record it. Again, what's every little mark worth? Okay, so from there to there is 100, isn't it? So it's every little mark worth. So what's the speed you're going currently? And what's the difference? How much more speed do you need to take off? So what's the difference from that to get to 810? All right. A little clue for you. 810 might be in between there. But you won't need actually to mark it, you're going to work it out by counting on, aren't you? Okay? As you escape the Earth's atmosphere, you'll be hit by radiation. This has to stay at a safe level. The level is 3.75 rad, okay? How much over the safe level is your ship if the level is shown below? 3.75, work out what that is. Work out what we're showing on here. So that's, think of that, that's 5, that's 6. That must be 5 point something, mustn't it? Okay? Yeah? Alright, that'll help you a little bit. Parents might need to help you, this is quite hard, this one. And work out the difference between that and that one there. It's quite a hard one. Okay? If you can't do it, don't worry. Let's have a go. Alright? So you don't have to do that, that's a bit tricky. And these ones now you don't have to do. So that one there is an extra, and these last ones are extra, so you don't have to do these. The temperature of the ship's hull needs to be carefully watched if it falls below -15. The ship will fall apart if that's the case. Check the thermometer below, are you still safe? These are negative now, these are minus numbers. Okay, so what is the reading? So if that's 0, sorry, I'll give you a little clue. -2, -4, -6, -8, -10. Remember, minus numbers. Alright, so what's the reading? Are you still safe? Is it below -15? -16 is below, isn't it? Yeah, -17 is below. -14 is better, isn't it? Okay. Last two. Remember, you don't have to do these, they're hard. As you enter Mars' atmosphere, the temperature of the hull cannot reach more than 450 degrees Celsius. The thermometer below shows the temperature. Are you safe? So look at the measurement again. What's each one worth? Are you safe? What is the current temperature? How much can the temperature rise until it becomes unsafe at that temperature there? That's quite straightforward, that one. And the last two. Whilst on Mars, you need to fix your ship's electrics using an ammeter, which measures amps. Okay, an ammeter. You need to have at least 43 amps for your ship's electrics to work properly. How many amps do you have if the reading below is correct? Look at the reading again. What's every little marker worth? What is the reading? How many more amps will you need? And the last one, during your stay on Mars, you must collect 355 kilograms of rocks. The meter below shows how much you've collected. How much you've collected so far. So look at it again, look at what every mark's worth. How much you've collected so far. How much more do you need to collect again to show your workings? I don't mind if you use your calculator. It's not about you working out that necessarily so much. It's about you understanding what you need to do. Alright? So, there's lots and lots of different problems there. Lots of problems. All to do with weight and to do with scales and working out the difference. Have a good go. I look forward to seeing your answers. And if you can get them all right, then you can go to Mars. All the best.